In this video, we're going to finish up section 2.1 with the linear transformations of data. You're going to be able to describe the effect of adding, subtracting, multiplying, or dividing by a constant on the shape, center, and spread of a distribution of data. So we're going to take just a couple different examples. I'm going to make up my own data set for these two examples. We're going to work on the notes here. So the first one, we're going to do the impact of adding a constant. We're going to enter the ages in years of all your classmates into list 1. You're going to calculate the measures of center and spread, record them in the data table below. So I'm going to make up a data set based on what ages probably should be for students. So 17, 18, 16, 17, 17, 18, 17, 16, 18, 18, 17. I'm going to throw my age in there at 28. So we're going to put the data values here into L1, and we're going to find mean, median, standard deviation, range, IQR, all that good stuff. So you're going to go to your calculator, and just a reminder that you'll notice that my calculator is much older than most, so it might look slightly different compared to the new operating systems. Press Stat right here. You're going to go to Edit to edit your lists. Into L1, we're going to type every number from the data set. The most action-packed part of this problem. Please take your time to make sure that you actually go through and hit every single one. So I had 13, I have 12 data entries. Let's count 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. That's 3 4s. I'm at 12. I'm good to go. So what you're going to do now is you're going to press Stat again. You're going to go to the Calc menu, one variable stats. Now in the newer calculators, it actually has options for which list you want to go for. This calculator, the default's L1, so I don't need to press anything. I just press Enter, and all the information pops up. So my mean is 18.083. I'm just going to put 18.08. So mean 18.08. I guess we can put 3 repeating. Median, that's going to, if you scroll down on the menu here, median's right there, 17. Standard deviation, that's the S of X right there, 3.203 or 3.204. Range, largest minus smallest, so 28 is our max. Our min is 16, so it's going to be 12. 28 minus 16. And then lastly, IQR. Q3 is 18, Q1 is 17, IQR is 1. Now, this operation could look different on the newer calculators. I'm going to show you how to do it on this one. I'm going to take L1, I'm going to add 10 to every single data value and see what happens. I'm going to make that into list 2. So here's what you do. If you look at your calculator, on the numbers in yellow, or in my calculator is yellow, another calculator is blue, L1, L2, L3, L4, L5, L6. So you take L1, let's get this out. Take L1, you're going to add 10, and you're going to store it, STO, the arrow, you're going to store it as L2. So second L2. This is what it should look like. I'll zoom in so you can see it. On an older calculator, you can zoom out. We're going to press Enter, and if you look here, all the data values I just entered, every single one got a 10 added to it. So 17 became 27, 18 became 28, 16 became 26, and so on all the way down. So we're going to now do one var stats for L2. So you go back to Stat, Calc, one variable stats. Now if you press Enter again, it's going to redo L1. On the newer calculators, actually have you type in the exact list. You have to type in L2 next to it. This tells the calculator, I want one variable stats for L2. If you don't type anything, the default's L1. Press Enter, and you get all the same information. So mean, 28.083. 28.083. That's repeating. Median, let's scroll down. 27. Standard deviation, SX, 3.204. Range, min or max minus min, 38 minus 26, that's 12. And IQR 28 minus 27, Q3 minus Q1 is 1. Let's take a look. Things that didn't change: standard deviation, the range, and the IQR. Things that did change: these two, the median and the mean. So when you add, or even if you subtract, doesn't matter, a number or a constant, it actually shifts only the mean and median. And you'll notice that those are both measures of central tendency. So conclusion here, the mean and the median both increase by 10. And from there, you can essentially say whatever you add or subtract to the data set, the mean and standard deviation will follow. So that's the measures of central tendency. So measures of center. Those are both affected by adding a constant. What's not affected? Spread and the shape, essentially, but the spread especially. The measures of spread are unaffected. And you could think about it as, like think about a data set, just a curve that looks like this. Here's a number line. The effect of adding or subtracting even a number, add, let's say a letter A, number A. If you add it, you essentially just take this graph and you shift it like a translation in geometry. This doesn't change, the width, the range, the standard deviation. This doesn't change in this direction. All you're doing is you're taking this and you're shifting it over here. So the center is what changes. Spread does not change. Shape does not change. Only the center changes. This happens if you were to add A or if you're going the other direction and subtracting A. It doesn't matter. Only the center changes. That's when you add or subtract a number. The next situation could be multiplying or even dividing by what's called a scalar or a constant. Let's see what happens here. So we're going to keep the same data. I'm going to clear out my data. I'm going to go back to stat, edit. I'm going to clear out L2. And that way I have a clear L2. So if you ever want to do that, you go to L2, you press clear. Don't press delete, you will delete the entire list. Let's quit, and let's take our list and let's multiply it by 2.54. I know it says L4 and L3. We're going to change that to L2 and L1. So L1, this is going to be L2, L1. The same as before, you're going to do 2.54 times L1, and you're going to store that as L2. And you'll notice that those those ages are simply multiplied by 2.54, and all 12 of those numbers got multiplied by 2.54. Go back to your stat calc, one variable stats. Remember, the default's L1, so you must press L2 in there, so it tells the calculator that. Maybe I got some pen on my calculator. Let's get the mean, 45.93. The standard deviation, 8.138. The range, we're going to have 71.12 minus 40.64. And IQR is going to be 45.72 minus 43.18. And then median, 43.18. So 45.72. We'll do those separate subtraction problems right now. 0.18. 2.54. And then 71.12 minus 40.64. We get 30.48. And from the previous page, I'm just going to copy down the numbers really quickly. copy the mean, copy the median, copy the standard deviation, range, and IQR. Okay, so if you go down the list here, every single thing changed. So with multiplication by a scalar, it's not just the center that changes, but it's everything. It's the center and the spread. So the graph is no longer translated like in geometry where you're just simply sliding the graph back and forth. This changes the way the spread is laid out. So all measures of center and spread get multiplied by a factor of 2.54. So if you were to go back and look, IQR, for example, this is the easiest one to look at. The difference here was 1 between Q3 and Q1. What's the difference over here? 2.54. That just so happens to be the scalar because that's 2.54 times 1, 2.54. If you were to do these numbers, divide each of them by 2.54, you should get these 5 numbers here. Let's try a couple. Let's try the mean, for example. 45.93 divided by 2.54. I got 18.026, and that's exactly what we have here. We'll do one more. 43.18 divided by 2.54. I got 17 exactly. And you go on the list here, every single thing gets multiplied by a factor of 2.54. So both the center and the spread change. So both the center and the spread are actually affected, we'll say. Both the center and the spread are affected. Let's make a connection to the z-scores that we talked about in the first video. Z equals x minus x bar over s. If you think about it, subtracting the mean from each data value essentially shifts the data in one direction. But that doesn't change the spread. What does change the spread is when you divide it by the standard deviation. And for example, on the page 85 of Mr. Pryor's test scores, if you were to take all of your data and divide it by the deviations here and divide it by 6.07, you essentially are taking this value here, standard deviation 3.204, and dividing it by 3.204. And what that will turn it into in your translation is 1. And you'll notice that z-scores, we have the mean at 0 and standard deviations at 1, 2, 3, or negative 1, 2, 3, and everything in between. And that's the connection back to z-scores. So we know for a fact when we divide by s in this formula, we know that we're transforming the spread, or the measures of spread, by dividing by a constant. So, just to recap, when you add or subtract a number or a constant to an entire data set, it's essentially affecting the shifting, the center only. Only the center changes, the shape, the spread does not change. When you multiply or divide by a constant or a scalar, you'll notice that every single bit of information here, both the central tendency measures and the measures of spread, they all change by the same factor. In this case, it was 2.54, but it literally could be anything. So, addition or subtraction only changes measures of center. Multiplication, division changes everything, measures of center and measures of spread.